يعطيكم العافية شباب. Today we have لا compaction، بعدها دخلنا في soil water relationships، ما في، مش داخل، هذا الامتحان الثاني. ماشي. إذا موضوعنا هو فقط في الكلاسيفيكيشن فوليوم ويت ريليشنشيبس والمادة الابتدائية الأولى والكومباكشن، 4 مواضيع فقط. كل ما حليتوا مسائل أكثر كل ما كنتوا جاهزين للامتحان أكثر. ماشي. والمسائل فوليوم ويت ريليشنشيبس والكلاسيفيكيشن ركزوا عليهم من ناحية مسائل، وبقية الشغلات اللي يجيكم سؤال هيك ولا هيك في المواد النظرية في الكذا، مش مطلوب منكم تحفظوا اشي اكثر من اللي قلت لكم تحفظوه. يعني العلاقات السبعة الاساسية مطلوب تحفظوها، لازم تحفظوها، مش صعبة. الوتر كونتنت شو بتساوي، سبيسيفيك جرافيتي شو بتساوي، كلهم 7 علاقات، يعني مش هالشيء الصعب، ونفهمهم. في المدرج يا شباب، والساعة 4 ما تتأخروش عن 4 على أساس تلحقوا تقعدوا هناك. طيب يا شباب، effective stress concept، احنا حكينا في الeffective stress concept وقلنا انه ترزاقي وجهة نظره انه نستخدم الeffective not total effective. We try to prove if he is right or wrong, if it is reality or fiction, and it is proved that it is reality, right? Reality. We saw that no change occurred when we dealt with total stress. When we dealt with total stress, no change, whether we had no seepage, whether we had upward seepage or downward seepage, there was no change, which is not correct. So the change was obvious when we dealt with effective. So from now on we will deal with effective. Now in effective we had 3 conditions, right? No seepage, downward seepage, upward seepage. And I asked you a question last time. I told you that if the effective stress is 0 here and then it comes to be how much we found it in the upward seepage. You have the drawings in front of you. Upward seepage. It is it will be here, it will be Z gamma effective, right, minus IZ gamma water, right, IZ gamma water, right, at any depth Z in the soil. Now we said that just in this case we may have this to be equal to 0, right, just in this case. It cannot be in the constant, in the no seepage condition, right? Because there it is Z gamma prime only, right? And Z gamma prime cannot be 0 because neither Z nor gamma prime is 0. Then it is not 0. Now if we have downward seepage, we have Z gamma prime plus IZ gamma water, so it cannot be 0. But here it can be 0 in one condition, when Z gamma prime equals to IZ gamma water, right? So at certain conditions we may have sigma prime equals to 0, which means that Z gamma effective minus IZ gamma water equals to 0, right? Which means Z gamma effective equals to IZ gamma water, right? Okay, so I can say that I equals to Z gamma prime over Z gamma water, right? Mathematics. Then I equals to gamma prime over gamma water. This I, we call it I critical. Critical hydraulic gradient. This is critical hydraulic gradient. It is equal to gamma prime, which is gamma saturated minus gamma water, divided by gamma water, right? This is important. I critical equals to gamma prime, which is gamma saturated minus gamma water, divided by gamma water. Okay? When it happens, then we have sigma prime equals to 0. Effective stress equals to 0. Okay? What does it mean, effective stress equals to 0? Effective stress, we said that how much the soil submerged in water can hold. When it holds 0, it means that I cannot put any load on it, right? It cannot hold anything. It holds 0. Right? It holds 0. It looks like a soil, but it cannot hold anything. This is what I said, you remember the last thing I said in the previous lecture. In the movies, we see that a person, the actor, whoever is, even Tom and Jerry, they sink in the soil. Okay? We cannot help them just by coming and try to help them, because we will sink with them. Right? The only way to help them is through a rope, whatever, from away. Okay? And try to pull him. Okay? Now, this condition is not fiction, it's not cinema, it's not movies, it's reality. It's reality. How it happens? In certain cases, in the soil, water will go up. Okay? For example, in some area, it was raining, then the water will go up. Okay? The level of water will raise. Right? It will go up. At certain point, the load from above, the load from below, they will be equal to each other, and the resultant will be 0. It is a soil, normal soil. You will not feel anything different. Okay? But once you step there, you will sink. We call this phenomena quicksand condition. We call it quicksand condition. And just in case, you may think that it is related only to sand. It's not true. It's not true. It's not related only to sand. It is related to sand and to clay. That's why we call it sometimes soil boiling. Soil boiling. Soil boiling or quicksand condition. It is the condition when sigma prime equals to 0. Okay? Sigma prime equals to Z gamma effective, IZ gamma water equals to 0. This is what I already wrote now, if you remember. Then when we end up okay. Critical hydraulic gradient. Critical hydraulic gradient. Okay? The soil will not be able to hold anything. Even if you put a pen, it will sink. If you put a paper, it will sink. Okay? Now, how we know that we will have this problem? Old people in that area, because this is this phenomena takes place at certain time in certain places, and people will be familiar with that. People will be familiar with that. They will know it. Okay? People will be familiar with that and they will know it. They know by history that, for example, the first week of March always, or the first 2 weeks of March always, people are lost in the wood. And they will talk about ghosts, jinn, شياطين، دعت عليه امه غرق الولد، راح على الغابة ما بطل يبين، بلعته الارض، بسموها الارض الملعونة، جيدة للافلام والقصص والحواديت. هم بيعرفوا اهل المنطقة، كل الناس بيعرفوا، الكبار في السن بيعرفوا انه في المنطقة هاي في هذا التاريخ تقريبا في هالفترة الزمنية ماشي في المنطقة الفلانية في الغابة الارض بتصير تبلع الناس. هلا بغض النظر شو بيفسروها، جن، شياطين، زي ما حكيت لكم ايش ما كان يكون، بس هي علميا هاي هي. واضح؟ فشو بيعملوا هم في هاي المرحلة عادة؟ بتلاقي الختيار حامل عصاي طويلة زي ما بتشوفوا بالافلام، وبيكون ينكش الارض وهو ماشي. يدفش الارض قدامه، بيمشي بيدفش الارض قدامه. لما بتمشي في الارض، لما العصاية بتدخل بالارض بسهولة بوقف، هاي معناته المنطقة خطيرة، فبيبعد على منطقة تانية. واضح؟ غير هيك طبعا الظاهرة لا تستمر طويلا، لانها هي ناشئة عن حدوث equilibrium بين القوة من فوق والقوة من تحت. once the equilibrium is violated، اوكي، يعني زادت القوة من تحت او نقصت، زادت القوة من فوق او نقصت، انتهى الزيرو، صح ولا لا؟ مجرد نتحرك عن الزيرو راحت الظاهرة. اذا هي ظاهرة مؤقتة. معي انتوا يا شباب؟ هلا ليه انا ما حبيتش اقول انه رمال متحركة بالعربي؟ لانه في الرمال المتحركة مرات احنا بنحكي عن لوس ساند. اللوس ساند اللي هو الرمل العادي ما بيحملش قوة فوقيه، خاصة لما يكون على سلوبس، فانت بتيجي على منطقة رملية بتنزل معك. هذا ملوش علاقة في الموضوع اللي انا بحكي فيه، هذا له علاقة في المية في الداخل ترتفع. واضح؟ بس لانها ممكن تحدث في الرمل سموها كويك ساند كونديشن، ممكن تحدث في الطين بنسميها سويل بويلينج. واضح؟ ممكن تحدث في اي تربة، بتحدث في الغابة، بتحدث في الصحارى، بتحدث في وين مكان، لكن ما لهاش علاقة في انه الرمل loose. We have loose sand, no strength or low strength. Then once we step on it, then it moves. This is different thing. Okay? Now we are sure of the theory of Terzaghi that we should use effective stress. Okay? Let us move to have some realistic problems. Okay? In reality, how we can have problems. Let us have an example. Okay? This is an example. Example. Suppose I have 6 meters sand, okay, with gamma equals 16 kilonewton by cubic meter. What does this mean? Water, right? Or either I put it like this or like this, okay? This means we have water. Then we have 10 meters clay. This clay is saturated or dry or wet? Saturated. Once we have the level of water, then it is saturated. Gamma equals 18 kilonewton, etc. And then I have sand with gamma equals, now let me 18. Okay, and I will change this to be gamma equals 20. Okay, I have, in reality, I have 6 meters sand, 10 meters clay, 8 meters sand. Okay, this is sand. I have, don't draw, wait a minute, because there is a way we have to deal with these questions. Okay, we have 6 meters sand, followed by 10 meters clay, followed by 8 meters sand. Okay, and we have the water level at the beginning of the clay. It means at 6 meters below the surface. Okay, what I want to know is to draw the total effective and poor water pressure. My question may be, please find at point C, okay, the effective stress. Now what you have to do, I prefer to draw the stresses, all the stresses, the way we took. I will solve the problem in this way, because once you know how to do all of the job, then part of it is easy to be done. Okay? Now, I told you always take points at borders, right? Why we take points at borders? Because the change between the borders is linear, not constant, linear. Okay? Between A and B, the change is linear because it is a function of the height only, right? Gamma is the same, right? But here gamma 16, here 20, so there is a change. Here 18, then there is a change. If gamma was the same, then it will be linear. Okay? Now, please, once we have these questions, try to solve it in this way. We draw this and we draw immediately near them sigma prime and u. Okay? Sigma prime and u. Okay? Now let us try to do this together. Okay? Then I'll give you time to draw it. At point A, what is sigma? 0. ISS 0. Okay, I agree. At point A, what is sigma effective? U. Because there is no water above point A to give us U. There is no load above A to give us sigma. There is no submerged soil over A to give us sigma prime. Right? Now we go to point B. Point B. Point B. Total stress is 6 by 16, right? 6 by 16. Right? 102. 6 by 16. Right? What is the pore water pressure? The height of water above B. How? The height of water above point B. How much water above point B? 0. There is no water above B. Then it is 0, right? Total equals sigma prime plus u. 102 equals to 0 plus 102, right? So this will be, right? U equals to 0. Then sigma prime is sigma total. 102, 102. Now we go to point C. C at depth Z. Okay? Now, I don't want to find C now. Okay? Let us find D. And if we are drawing to scale, then it's easy to find C. Or I can tell you that C at depth 6 meters, then it's easy. Okay? Let us find for D. For D. It's 102 plus 10 multiplied by 20. Right? So it is 102 plus 10 by 20. 10 by 20, 200, 302, right? 302. What about pore water pressure? Do we have? Yes, how much? 10 multiplied by 10 multiplied by, right? Don't forget the unit weight of water, 9.81. 9.81. So this is 98.1. Now 3.2 minus 98.1. Who has calculator? You don't have calculator? 16 ليه؟ مظبوط 96. منين جبت انا؟ شايفين فوائد الكالكوليتر؟ 96. طيب يلا صلحوا هذا الكلام. $96. Here we have 96 plus 200. It's 396, right? 396 minus 9, 2, right? 296. 296 minus 98.1. 197.9. Are you sure? Okay. Can you help me? I will try it differently. Okay. I know that here the effective stress is the height multiplied by gamma effective, right? Gamma effective is 20 minus 9.81. 20 minus 9.81 multiplied by 10. Wait a minute. 101.9. Then there is something wrong.
20 minus سالب 78.1.
لا 20 ناقص 89 ضرب 10 كيف بده يصير معي
101.9 صحيح
101.9.
So it's different. There is something wrong. There is something wrong, huh? What is the wrong? Oh, there is nothing wrong.
في عنا زد.
Of course, we have 96 at the beginning, so we have to add the 96. You don't forget it. Add 96 to the answer. 1979. Don't forget the 96. Okay? Don't forget. The stress here is added to this here. Don't forget. Okay, we continue now. We add to it 8 multiplied by 18. 8 multiplied by 18 plus 296. How much? 440. Okay, now add 8 multiplied by 981. 8 multiplied by 981 plus 98.1. Don't forget. Eight multiplied by 9.81 plus 98.1. How much? مظبوط 176 كم 85% 58% سامحك فيهم كلهم ماشي 176 440 minus 176 how much لا بدون زائد لانه انا قلت ايش 440 ناقص 176 فانا ماخذ الاحتياط كل شيء من فوق 440 440 minus 176 how much 264 okay let us try it differently we say that 18 minus 9.81 18 minus 9.81 multiplied by 8 plus 197.9 264 almost. Okay? We solved it. Now, my question was, how much is the effective stress at point C? If I'm drawing to scale, I come here and say, okay, this much. Right? This much is C. Or, if C is known, for example, at depth of 6, okay, then I will multiply 20 minus 9.81 multiplied by 6 added to 96. Okay? Or I can make interpolation between 197.9 and 96 divided by 10 multiplied by 6. Interpolation. You have freedom, full freedom to use whatever method. At least you are free in this. So, this is a typical question that you may encounter in your happy life. What do you think? Let us try another question. Why not? أي وحدة 264 اكتب 264 وتضيف عليها 176 حسب الرياضيات المعاصرة 440 شايف الصدفة؟ ما احنا هيك عملنا بس إذا كنت مخربش جيد إنك تعمل تشيك على حالك.
الصفحة دكتور الأولى ليش صفر؟
وين الصفر؟
بي يو
عند النقطة A.
مش مية.
U There is no water above A, so it's 0. There is no load above A, so sigma is 0. There is no submerged soil above A, then it's 0. It's always 0 once we don't have anything above. Okay, are you ready? You see, for example, instead of dealing with 296, we are dealing with 196. 100 points different. See? Instead of dealing with 440, I'm dealing with 264, almost half. Almost half value. So, of course, see how much waste? Are you ready to move to another question? مين لسه بيكتب؟ Ready. Okay. Let us do this example. Another example. We have sand. Gamma equals 15 with units. Okay. No, gamma is not 15. Gamma is 110 PCF. What is PCF? PCF. Either we write it PCF or we write it like this. Pound per cubic foot. PCF. PSF. Pound per square foot. This is pressure. PCI. Pound per cubic inch. PSI. Pound per square inch. Okay? So either we write it this way or we write it this way. This way. Pound per cubic foot. Okay? So, and this distance is 10 foot. Okay? We have sand. Then we have clay, 116 PCF, and depth is 16 foot. And then I have water. Then I have clay, gamma equals to 120, and this distance is 20 foot. Okay? I have this condition. I used different units to make you familiar with two systems. Okay? The same way as we did before. This is point A, B, C, of course this is water, and D. And whatever in front, this is water. A, B, C, D. Okay? Let us do it together. At point E, A, sigma 0, sigma prime, U 0. So this is sigma, sigma prime, and U. At point B, use your calculator. U 0. Then 1110 1100. Okay? Now we go to 16 في 116 بلس 1100 2000 900 و56 2956 لحظة شوية. Still here we have U0, right? Because still there is no water. Then this will be okay. Now we will continue to have to calculate at point D. At point D, what we have 20 multiplied by 120 plus 2956 5350 56. Okay. Now here 20 multiplied by 62.4. 62.4. The unit weight of water in this system is 62.4 multiplied by 20 1200 48. Okay, 5356 minus 1248 4108. Okay, let us try it differently. We say 120 minus 62.4 multiplied by 20 plus 2956 4106. Okay, easy. Now remember, in the exam or in your life, I may not give you gamma. I may not give you gamma unit weight. I may give you E, G, W, water content, specific gravity, void ratio. Then you have to calculate gamma. Okay? Why? Because I want to check your knowledge. What gamma you will use? What gamma I will use here? Gamma dry. What gamma I will use here? Gamma dry. What gamma I will use here? Just once I have the line of water, below the line of water, gamma saturated. Above the line of water, gamma dry. If we go back to this question, what gamma here? What gamma here? What gamma here? Gamma saturated, gamma saturated. I want you to know what gamma to use. Okay? Because we assumed that above the water line, it's dry condition. Below the water line, it's saturated condition. Okay? Is it clear? Once it's clear, then I have this surprise for you. Don't draw it, because we will talk about it later in the next class. But I will explain to you one thing. Sometimes we are digging excavating in the soil, okay? We began with dry condition. It seems to be soil is dry. Okay, I can feel it. Soil is dry. And then as I'm moving downward, then I feel some humidity. Okay? Some wetness in the soil. The soil is wet. It's not saturated, but it's wet. I can feel it. Then this wet increases until once I am in the water. Okay? So I have water level here. I have dry condition here, but somewhere I have this area. It is not dry, but it is not saturated. It is not dry, it is not saturated. Why? Why is water here? Why we have water here? From where the water came here? Okay. Suppose what temperature? No. It may be it was raining, okay, and water still going through, still flow inside the soil. This may be a reason, but there is another reason. Okay. You remember, guys, you took this in physics and in fluid. If we have water and we put a pipe, standpipe, what will happen? Water will go up in this pipe. Why? Capillary rise. Remember capillary rise? Ductal osmosis. Capillary rise. That's why water or liquids go above in the tree to the roots, to the leaves. Okay? How water goes up in the trees? Because of the capillary rise. And this capillary rise, by the way, like this, okay? This tension will hold the water above to the height. We call it HT or HC, capillary rise, capillary height, okay? How much is HC? At what factors it depends? HC. If we have more water here, it will go above, right? It will go higher, right? This is one thing. What else?
Area.
If the diameter is smaller, then the height will be more, right? And also this type of liquid. The type of liquid, viscosity of the liquid, temperature, okay? Type of glass, okay? Type of the tube. There are many factors, right? Now, you remember when we spoke about soils, we said that soil is solid particles and voids, right? And these are very small. So I can consider as if this is a tube. You see? Small tube. The water will go in this small tube and it will go up. So what we have is as if water will go like this. Okay, now when we found the value of pore water pressure, we said that how much water above the point, right? Because the pore water pressure is a pressure downward, right? But now what I have a pressure downward and I have a pressure upward. So the value should be the resultant of both, right? So this area, we call it area of capillary rise. Capillary rise. Area of capillary rise. This area, here we have gamma saturated. Here we have gamma dry. But here we have gamma wet. Okay? And here water goes down. Here water goes down. Here water goes down and up. So we should deal with this. Okay? How much the height of the water here is HC that we just spoke about it. Remember HC? Right? HC, right? HC is a function of how much water we have here. Right? So how much water here? Now U will equals to minus S this is the equation. You may not write it, we will explain it next time. Okay? يعطيكم العافية شباب.